Good day again to everyone partaking in this symposium. My name is Marvin Lewis, and the title of my presentation is Using Geographic Information Systems and Remote Sensing to Aid Genetic Conservation at the International Cocoa Genebank, Trinidad. The MOCCA Biodiversity Project seeks to establish an ICGT spatial database, which is one of 4 initiatives within the project. The aim is to develop a curated information system. This initiative is funded by the MOCCA project. The outline of my presentation is as shown. I will now provide some background information on the ICGT. The ICGT is situated at Centennial on approximately 100 acres. It is renowned to possess the largest and most diverse live collection, estimating 2,400 cocoa accessions. The Cocoa Research Center has been the curator of the ICGT for over 30 years. Activities at the ICGT include field exploration, agronomic operations, defining core collections, identification of collection gaps, germplasm characterization, evaluation, and the use of plant genetic resources. Genebank curation is being used to support pre-breeding programs and the development of molecular markers to support cocoa breeding programs at CRC UE. A number of these accessions have also been used in a variety of graduate sponsored and staff research projects that have yielded considerable information to date. The derivatives of this project will also support users of genetic resources, both locally and internationally within the cocoa community. While the Genebank has yielded lots of successes to date, it is still faced with numerous challenges. CRC undertakes a census on a bi-yearly basis, which also yields considerable data that is not always captured and curated to make decisions. CRC is not only challenged with plant resources, but infrastructural rehabilitation. Existing bridges, sheds, and drainage are required for a safer and more inviting environment. It has been observed that over the years, genetic erosion have greatly impacted the Genebank's collection. The biannual census have reported that there is a reduction in some genetic resources. Plots have been noted to possess off-types. Labeling of accessions and trees have not in all instances been properly identified. Much of the data collected from the Genebank is held in Excel sheets, project reports, paper maps, CRC publications, and GIS platforms. The data is therefore not readily available to allow decision-making with regards to the curation of the Genebank or support researchers to access the information they require. The overall goal of the database is to make data from the past 30 years plus future works accessible to researchers and research students, as well as to the users of GeneBank genetic resources. The goal of a curated database is to allow timely decision-making that would improve the effectiveness and efficiency of curating and managing the gene bank. This will provide an improvement to the workflow of CRC and its collaborators. Another goal of the project is the development of numerous curated data resources and technology products and services. The database will ensure that the data is duplicated, curated, and secured for posterity. The Campus Information Services of UE, along with the support from CRC, has initialized the database as of January 2020. The database uses the standard query language and will be populated by the various departments of CRC. A data security strategy will involve access protocols for data access. CRC will develop standard operating procedures for data entry, management, and use to ensure an updated database. This standard operating procedure will reinforce data confidentiality and access. CRA UK, along with CITS, will assist CRC with the development of a barcoding system that will allow the unique identification of trees and accessions within the gene bank. This system will allow field-based data entry and retrieval. The organization, integration, and dissemination of data collected from various sources will be an ongoing undertaking by CRC. A geographic information system can capture any activity, phenomena, or incidents which occurs at a specific time and location. The GIS platform will be integrated as part of the database to facilitate all the related gene bank activities. At this present time, field reconnaissance is ongoing at the ICGT. Data collection at the ICGT involves Global Navigation Satellite Surveying, GNSS for short, and remote sensing applications. Field reconnaissance involves the establishment of ground control points to assist both ground surveying and aerial mapping. Surveying tree locations and other assets of interest, such as bridges, drains, hydrants, etc., were also undertaken at the gene bank. Remote sensing can be used to procure thermal and multispectral imagery. Remote sensing can also be used to carry out field inspection. Thermal imagery can detect areas compromised by heat stress, thereby informing the irrigation strategies. Multispectral imagery can be used to assess plant health and, by extension, the potential for plant yield. Here is an example of using a drone to undertake field inspection at the gene bank. Satellite imagery can be used to investigate change detection of the gene bank over time. Here we captured data from as early as 1994 all the way up to 2019. And it goes without saying that the more imagery that we can collect is the more analysis that we can perform. We now take a look at the database architecture. The database will contain two interconnected databases. The first being a tree database that uniquely identifies every single tree at the ICGT with a range of data fields regarding the tree. The second database would be an accession or plot database that uniquely identifies every accession and all the related information. This database will be supported by the acquisition of tree and plot GPS data, which would result in a GIS map of all plots and trees at the ICGT. This will allow the data collected to be viewed and analyzed on a geographical scale, or even correct the existing data. Here is an example of the present database interface. This is phase one of the database. And as you could see, we were viewing it on the desktop plant. A number of curated data sets will be developed to support the international community with regards to access of germplasm at the ICGT. A DNA fingerprinting service will be developed and offered by CRC to all cocoa growing countries with working germplasm collection to verify the identity, the fidelity of the collections that they have. Based on the curated data, a refined basic cocoa germplasm collection and a strategic cocoa germplasm collection will be identified, prioritized, and duplicated. Pre-breeding to support breeding programs in other countries will be developed using molecular markers. This is just one of the services that will be offered to other countries. Here we have an example of one of the end products of the Spatial database project. This mobile application can be used in the field without a data connection. It can be used for site inspection census, scheduling of works, research, etc. It allows the user the opportunity to capture any data of interest and append it to the corresponding tree plot infrastructure that is of interest to that user. More importantly, the attribute values for each entity throughout the gene bank can be captured at any given time and as many times as the user requires. The captured data can then be uploaded from the mobile device to the database at the convenience of the user. These are just some examples of the assets that could be collected. Here we have an example of the ongoing collection to date, where we collected assets such as roads, hydrants, drains, shade trees, just to name a few. So I thank you all for viewing my presentation, which is using geographic information systems and remote sensing to aid genetic conservation at the ICGT Trinidad.